Hi, welcome to the Open Compute Project podcast. I'm Rob Coyle with the Open Compute Project, and I'm here with Jaswanth Vutukury, the lead EMC engineer and ISCE hardware product integrity at Meta. Jaswanth, welcome to the podcast.
Thanks, Rob. Thanks for having me here.
We're here to talk about EMC, electromagnetic compliance, and tell us what's the problem. Give us the 30-second. What's the problem with EMC today?
So if you take our AI servers or AI server racks that are being deployed into data center, before any of these server racks can be deployed, it has to pass EMC testing. That's a regulatory gate. What it means is FCC makes sure that all the AI servers or any electronics, in fact, can coexist. So for this, we need EMC compliance, and if there is no EMC compliance, we don't get FCC approval, and we cannot deploy in data centers.
Well, when you presented this is, to me, I wasn't familiar with this issue. I mean, you see it as a major bottleneck.
Yes, true. Right now, the problem is the test infrastructure cannot keep up with where the AI hardware is going. So in order to get this approval, we need to test our AI server racks. And currently, for the next generation of AI racks, EMC lab infrastructure, it doesn't exist.
Interesting.
Yeah.
You've seen this across, you're at Meta today, but you've seen this across multiple industries before that. What makes AI infrastructure different compared to the other times you've seen this?
Yeah. Before working at Meta, I was in autonomous vehicle industry, and before that in consumer electronics. What's different here is the sheer structure and scale of the AI racks. So, and how they are evolving. When we test AI racks, we have the server rack, the cooling system, and then the high power rack. Given the size of these, we are hitting some bottlenecks where EMC labs cannot accommodate due to the heavier size of these AI racks and then the power feeds. This is not something that we have seen in other industries, and our AI server racks are evolving so fast. Now the cycles are around 12 to 18 month cycles, and in the future they could be even less. But the EMC labs, they take about a year to upgrade, whether to build new chambers or heavier turntables or get the power that those AI racks need. And by the time these upgrades happen, we are already working on next gen. So there is this isn't like a one-time gap. It's a widening gap as we move from generation to generation. Unless we try to fix this gap, I think this is going to become a bottleneck.
So what I'm hearing you saying compared to other industries, just for those in the audience who aren't familiar, if we were doing this with EV testing, you have a fixture. EVs are similar in some regard, right? If we've built a lab for EVs, the next version of your EV or the next model of it is somewhat similar to the previous generation. But in AI, we're moving so fast and changing so quickly, and the physical footprint, we'll get into all the details, but things are changing so fast that the server of 2 years ago is not the same server today. Is that what I'm hearing?
Yeah, that is true. And as we are, if we look at the future that's ahead of us, the GB300s or AMD ASICs, they are pushing out these new ASICs much faster than before. So we have to build the racks much faster than before. And as you mentioned, exactly where we were before 2 years ago isn't where we are now, and definitely for the next couple of years or next 4 years, we will be evolving much faster.
Interesting. Well, before we get into testing and actually how the testing works and why that is a challenge, let's talk a little bit about the importance of having the testing. You mentioned that all electronic devices per the FCC requirements. So it's a legal requirement. It's a regulatory requirement. We have to have it. But why do we have it? And if we didn't have it, what does failure look like in a data center if we don't have EMC compliance?
First and foremost, electromagnetic compatibility, why FCC or any regulatory body in the country enforces it is we want to make sure all electronic devices coexist. What I mean by that is one electronic device shouldn't interfere with another device. And in order to make sure that this happens, in US, FCC sets limits on how much electromagnetic noise say a device can emit. Uh, and we see this in our every day-to-day life. If you are using your Bluetooth headset, and let's say you are on a call and you went to microwave to heat your food, uh, in that scenario, most of the time we have many of the viewers have experienced some call drop. If you're talking to other person or if you're listening to music, you could hear some stuttering.
Yeah, or some very strange noises
Yeah.
sometimes.
This happens because of electromagnetic interference. Uh, so the headset that we use uses Bluetooth at 2.4 gigahertz, and microwaves also operate at the same frequency. So because of this interference, we see that minor inconvenience of stuttering or call gets dropped. But when we take it to data center, it's not a minor inconvenience anymore. It could also be potentially dangerous. If we use our liquid cooling racks, we use liquid level sensors and leak detectors to catch any coolant leaking in our servers on server racks before it damages the equipment. Let's say if a neighboring rack is emitting much higher noise, it could give a false alarm. The leak detector sensor might trigger or it may not trigger. So we could see the sensors malfunction and then we might miss a real leak, uh, or it might give you a false alarm. Either way, it's a serious operational problem. So this is one of the examples that we see in data centers. That we might see in data centers if we don't comply with EMC regulations.
Interesting. So in that process, where where's the breakdown? As we're developing new data centers, we're adding in new sensors, we're bringing in different servers. What's not working now about how we approach it?
What's not working now is, so in order to deploy our our AI server racks or any rack, we need to have EMC certification. So currently, like almost all hyperscalers or ODMs, the hardware development process is we have a prototype where we test whether a new server or subsystem level as a proof of concept. We will have a prototype hardware. And then next build phase is we call engineering validation test, where we do all engineering validation and EMC compliance is part of it. So usually we test servers around this stage to fine tune our design, how things are, whether the hardware and software are working as expected. So in EVT testing, we usually use servers, not the racks. And when we come to DVT testing, design validation test, we do full integrated rack. It could mean like we have the entire AI server, power rack, and then cooling. And this is where we are getting bottlenecks currently. Um, we are doing everything in the process.
Hmm.
We are testing early in EVT, and we are thinking early in the phase, in the development phase, uh, how to test. But when we get to critical validation, which is around DVT time frame, uh, we are not able to find EMC test labs. So these EMC test labs, the bottlenecks that we are seeing are uh, one is due to the sheer size, weight, and the power requirements. Test labs are not able to support. Uh, to give one example, most of the test labs in US and in Taiwan, they can support up to 3,000 pounds. Uh, what I mean by that is when we do EMC testing, we place the server rack on a turntable, and the turntable rotates 360 degrees, and we have an antenna 5 meters or 10 meters away, which captures the noise emitted by this server. So we need to capture the noise from each and every angle to so that we can identify what's the max noise that it is emitting, and whether we are passing regulatory compliance or not. So the current bottleneck, one of the current bottleneck that we are seeing is the turntable. The turntable cannot handle both the AI server power rack and also the cooling rack combined. And in some cases, it may not be, most of the labs cannot handle just the AI server rack itself. So there is a physical limitation to how we are going to how the labs can test.
Interesting. So I'm picturing, to your earlier example of the microwave, I'm picturing a giant reverse microwave, not one that is emitting, but one that is sensing whatever you put in this giant microwave type room with a turntable in the middle.
Yeah.
You kind of mentioned both. You mentioned size and weight. You have the facility itself to be able to take a rack, because now historically we had cooling, most of cooling, or definitely an air cooling, and compute hardware and power hardware all in one rack. And so
Yeah.
I would imagine that most of the facilities were set up for that. But now we've disaggregated into
Exactly.
3 racks.
Yeah, that's what is happening now. Like most of the labs are built for traditional IT equipment. They are not built. They are not built for the AI hardware that we are seeing now. And I mentioned about the weight, and upgrading a turntable isn't just buying a new one. There should also be structural reinforcements so that the turntable can support the weight and to be able to rotate. Uh, yeah, on top of this, we also need some chamber modifications, which require significant capital investment. So this is one of the wall that we are hitting, and the other one is power. Uh, um, as you mentioned, traditional IT equipment has power in the same rack, but now we are having separate racks, which are up to 1 megawatt. And in last year OCP, we have seen 1 megawatt racks, and this year I believe we will see like much higher, more than 1 megawatt racks.
That's hard to believe.
Yeah. And if you look our future roadmap or what might be coming, so this might increase given the history what we have seen in last couple of years. So most labs are also not built to deliver this kind of power to a test chamber, and without powering it on completely, without running it at max speed or whatever the speeds and features that we use in the data center, we can't test EMC emissions properly if we can't provide the power to the system. So this is another wall that we are hitting. And another one I mentioned is size and scale. Since we are having individual AI rack power and cooling, they have larger footprints.
Mhm.
End to end, it could be 5 meters or 10 meters. If you take the designs that were shown in last year OCP, they were huge.
Yeah.
The
You have
cooling,
the ORV3 wide rack.
yeah.
Now
What
add on power and cooling.
on top of it, yeah. So the length might come up to like 5 to 10 meters, and the turntables that I have mentioned before, we have seen up to 5 meters of turntable. Now we want to increase. Now the need is to increase the size of the turntable as well because of the size and scale of these larger footprints. And to do this, we have to increase the chamber dimensions. So building a bigger chamber means major construction and investment. So currently we are in this perpetual catch-up phase. it takes a year, about a year, with the right capital investment, to upgrade or build a new chamber. But AI racks are evolving every 12 to 18 months, and they could be evolve even faster in next few years. So even if the lab starts upgrading for the current generation, by the time they finish construction, we will be new. We are already pushing past their new capabilities. So this gap never closes if we operate the way industry and test labs are operating.
This sounds like a similar but much more challenging problem as third-party data center providers are facing, and I think most of the audience would be familiar, is if I build a data center today, what am I anticipating the needs of the IT hardware it has to serve? And this is like a condensed version of that problem.
Yeah, similar. So for the new data centers that are being built, they need to know the power requirements as well as they need to forecast uh, how the power requirements. For example, I'm taking power only as an example. Power requirements change our network requirements. So a lot of things needs to be baked in. If they don't have that information by the time they build the data centers, data center facility, uh, it might not be what we need at that time. So in a similar way, EMC test labs, even if they try to start building for current requirements, in 1 or 2 years, we might be pushing past those new capabilities that they built.
Yeah, I can imagine. I'm thinking back to my earlier days in school. I started in aviation, and so I was close to the avionics piece and getting inside these Faraday cages and all that. It's
Yes.
it's not just that this is a room that has to be built. I also imagine the turntable itself is highly specialized. It itself can't emit EMF, or it has to be uh, you know, accounted for, because now I don't know if I'm testing the turntable or am I testing the device. So this isn't a simple project. It's understandable that, and actually I'm a little surprised that a year is enough time, because it's a highly specialized project to create one of these labs.
Yeah. Uh, Again, the year is enough time with enough capital. Uh,
Yeah.
yeah. So, and if we look at this, the path forward should change. We can't take the same path if we are supposed to fix these bottlenecks.
Which one's the hardest to solve for, do you think? The power, the weight, or the physical dimensions?
I think it's the power. Again, this is my perspective. In order to secure 1 megawatt or more power, we need the city to be able to supply that power to us. That's one of the major challenge that we have been seeing for our internal lab.
Yeah, and I guess it's now we hear a lot of discussion around things like 800 volt. It's not just the amount of power that has to go to the facility, but then it's also, we need to consider the distribution to the rack itself within the facility too.
Yeah, that's right.
So, uh, do you have a time where, as we get kind of closer to this problem, I think we understand why it's necessary. We have a bit of an understanding of what the bottleneck is. Do you have an example of where you've seen this play out firsthand?
Firsthand, yes. Currently, there are 1 or 2 labs in the world that can support the weight size that we are currently working on, and we have. Uh, so one of the issues that I have been seeing is if we once we test this and then if we find some failures and if we want to fix them, in order to book another round of testing, it's becoming very challenging because all the hyperscalers are going after these 1 or 2 labs that are in the world. So timing fix if there are any issues with respect to EMC. In order to fix them, we are taking much longer time than we used to take before, just because labs are not available. And I don't know what we might see in this year OCP. Uh, I think this problem might uh, continue, or even the timelines that I spoke about, and they might increase.
Okay, so you mentioned there's one or two labs available. They're in massive demand. Uh, What happened when it got narrowed down to the two labs? Like, what's the conversation like with a lab that can't handle your requirements? What does that sound like?
Yeah. So this is most of the time. This is what we hear from labs. First thing is the labs find out about our requirements when we show up to the lab. During our development phase, we start looking for labs, and then when we talk to them about like the power requirements, the size and weight that it has to support, uh, usually they are not prepared for it because they don't have any early visibility into future rack roadmaps.
Hmm.
So this is what is happening today. So they are finding out about requirements when someone shows up, either to get test time or schedule test time. But what needs to change is we need labs to be part of OCP planning process. See what's coming 2 to 3 years out. Uh, like I mean, they can hear from news and all, but unless one hyperscaler or the industry themselves talks to the labs and then say this is what we are anticipating in coming 2 to 3 years, they can invest and build ahead of demand and not react after it. What's currently happening is they are reacting when we go and ask for when we present our requirements, when we show up for testing. They are when they see this demand from multiple hyperscalers, they will start building it. But again, once they build it, we will be in our next generation, and then this catch up keeps on happening. The labs has to catch up. One thing they can do is, or we can facilitate is, bring EMC labs into OCP ecosystem. They can find out what's coming up in next 2 3 years based on the roadmaps, and they can invest and build ahead of demand.
And not just for Meta. Certainly you could communicate what your requirements are, but that all the other major buyers and manufacturers are going to need these services as well.
That's right. Yeah, I think it's a problem that I believe everyone is facing, given how the industry is moving. And one of the reason to come into this podcast is to voice that this is a bottleneck. And then if I hear from other hyperscalers, maybe uh, we can collaborate, not just with hyperscalers, but also with test labs. So if we bring the test labs into the OCP ecosystem, I think that would benefit for everyone. And another, again, this is the current demand when we talk about EMC testing, that there are only couple labs and they are seeing lots of demand. Sometimes EMC labs might be thinking about the investment that they are going to
Sure.
to build these labs. They want to get the returns. Everyone wants ROI, and we don't know how long this AI server racks or the AI infrastructure boom is going to exist. Uh, if we have maybe like these hyperscalers, maybe they can collaborate with EMC labs and then invest. Since they are going to use it, they might as well invest. That's one angle that I am thinking, and maybe as a OCP, I mean OCP as a community should think more into, or at least brainstorm what we can do so that this bottleneck doesn't choke us.
Yeah, this sounds like a request for industry alignment that is probably not highly proprietary. The EMC standards are to meet a existing regulatory requirement. So I think it makes a lot of sense. So I heard kind of the first piece is you need the labs to be an audience for this. So you need them to join the ecosystem because they need to hear the conversation and see what's happening in 2 to 3 years. So that's kind of the first piece. And then the other is around collaboration amongst the hyperscalers. Is there anybody else in that conversation outside the labs and the hyperscalers? Like you guys set the requirements, but
Yeah, so we haven't engaged with any hyperscalers as of now. But it's not just hyperscaler, even the ODMs who are building who are building these AI racks or like cooling and power racks, they are also seeing the same issue. So that's how I believe it's an industry issue. But we are yet to collaborate with other hyperscalers and ODMs to solve this bottleneck. And I want to use this podcast to bring this up, and then possibly maybe in the coming OCP, we can discuss more about how we can address this bottleneck together as an industry. And uh, maybe like before OCP, we can try reaching out to a few other partners of OCP who are facing the same issue, and then we can churn out a white paper on how we can fix or how to like how what approach we can take to mitigate this.
yeah, that sounds like a great first step. We've seen lots of other projects find alignment that way. White paper is a great way to start. Just describe the problem, and a potential solution. It also sounds like similar to how end users love to have a multi-vendor ecosystem. It's beneficial to the labs to have multiple customers. Not just that they're going to make this massive investment and make sure that the one customer still has a similar need or growing need for more powerful, heavier, larger racks, but that there's multiple customers that also have the same need. So, for those reasons, then you also mentioned the OEMs have similar challenges. Aside from the labs, you're all in our ecosystem already. So this does seem like a good home for this conversation.
Yeah, that's exactly why I reached out for the OCB podcast. It's a perfect forum, at least to get the message out, and then we can collaborate with other OCP members.
Let's bring it home because I think you did a fantastic job in helping me understand the problem and the challenge, and we got to get into some details about what the obstacles are. We're starting to come up with ideas on why OCP might be a good place for it. So I'm going to break it into two pieces. First, the hyperscalers and OEMs, because most of them are already part of our ecosystem and they're probably a big part of our audience. After they hear this podcast, the next week, the next day, what can they do? And then I got one more follow-up for you too.
Yeah, when we can all get together, think the challenge. So we can collaborate on hardware certification, like how to approach. Is testing the only way we move forward? Are there any other alternatives? Can we leverage simulation, or what else can we do apart from this testing? So I think we can brainstorm how we want to approach this problem, not just building the lab capability, but what else do we have? We can brainstorm, and then together as an industry, we can collaborate and then try to fix this bottleneck, not just from EMC lab perspective, but thinking about alternate solutions as well.
So we need to find a home for this conversation, and I know the right people at the foundation. So I'll get them plugged in. We'll add a link to this podcast and the video, and we'll find the best project location for this. And so we'll put something together so people can reach out.
Yeah, that sounds very good. And thanks for your help.
Yeah, of course. Happy to. And then I'm going to point it directly to the labs because that's kind of our internal conversation and those who want to get closer and more engaged on the OCP side. So, I asked you about somewhat of the companies that are already familiar with our ecosystem, the end users, the OEMs. But what about the labs? Speak directly to the labs. What can they do next?
If they are part of OCP, they will know what we are building in next 2 to 3 years. And this isn't a meta-only problem, the bottleneck with respect to EMC testing that we are facing. I believe every hyperscaler and every ODM is hitting this bottleneck. And once they are part of OCP, they can engage with all hyperscalers and ODMs and then identify if everyone is hitting this bottleneck. And it's a pretty competitive space now, building the lab infrastructure. I think a shared approach for this benefits everyone. And OCP is the perfect forum. We are ready to collaborate on this hardware certification and building up the labs.
Excellent. I think that's pretty direct. So that people know how urgent this is, you mentioned Bottleneck, and earlier when we were talking, you said we have a problem today. That sounds like a scheduling problem. Do you got a rough estimate on like when this becomes a hard stop? Like it's a growing problem. Any guess?
It could be 6 months to 1 year. It's not far away.
Well, then we need to act fast. Jaswanth, thank you so much for joining the podcast, explaining this challenge to us, and we'll get the word out there, and we'll get some people to start having this conversation.
Thanks, Rob, and thanks for facilitating this OCP podcast where we can come and talk about our bottlenecks and the challenges that we are going to face in next year or so. And also providing this opportunity where we can talk directly to OCP members and test labs that are going to be part of OCP soon.
I'm honored to facilitate it. Hopefully we'll have an update soon. Maybe the next time you come on the podcast, we can learn how we solved this and how we brought the industry together. All right. Thanks so much.
Okay. Thanks, Rob.